Understanding Newtonian Physics, a journey through fundamental concepts. Hello everyone, welcome to our English language learning channel. Today, we're going to explore an exciting and foundational topic in science, Newtonian physics. Whether you're a science enthusiast or just curious about the basics of physics, this video will help you understand the key concepts and vocabulary associated with Newtonian physics. So, let's dive in and discover the world of motion and forces as explained by Sir Isaac Newton. Sir Isaac Newton was a 17th-century scientist who revolutionized our understanding of the physical world. He was not just a physicist, but also a mathematician, astronomer, and author, making significant contributions to various fields. Newton is most famous for his laws of motion and universal gravitation, which laid the groundwork for classical mechanics. These concepts are fundamental to understanding how objects move and interact in our universe. First law, law of inertia. Newton's first law, also known as the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This law introduces the concept of inertia, which is the tendency of objects to resist changes in their state of motion. Second law, force and acceleration. The second law explains how the velocity of an object changes when it is subjected to an external force. It is often written as F equals MAF equals MAF equals ma, where FFF is the force applied, m is the mass of the object, and AAA is the acceleration. This law shows that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. Third law, action and reaction. Newton's third law states that for every action, there is an equal and opposite reaction. This means that whenever an object exerts a force on another object, the second object exerts an equal and opposite force on the first. This law helps us understand interactions like a rocket launching or a ball bouncing off a wall. In addition to his laws of motion, Newton formulated the universal law of gravitation. This law states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law explains phenomena like the orbits of planets and the tides. Newtonian physics has had a profound impact on science and our understanding of the natural world. It is the foundation of classical mechanics, which is used to describe the motion of macroscopic objects from projectiles to planetary motions. However, it's important to note that Newtonian physics has its limitations. It was later expanded by Albert Einstein's theory of relativity and quantum mechanics, which describe the behavior of objects at very high speeds and very small scales, respectively. We hope this video has helped you understand the basics of Newtonian physics and the incredible contributions of Sir Isaac Newton. Remember, physics is not just about complex calculations, it's a way of understanding how the world around us works. Keep exploring, and don't forget to subscribe for more English language learning content. See you in the next video.